Let me go back. And how do we print out the elements in the array? Typically, we would need a nested loop. And for this week, I don't want to dive too much into the nested loop. I just want to show it to you. And then for those of you who may not be so familiar with the nested loop, you can take it for granted for this week. And then I'm going to maybe do a little bit of flowchart, some simple ones to really show to you how you can analyze nested loop before I do more utility methods next week. Okay, for this week, let me just show you the standard way of printing out, or at least to go over every element in the array. So the idea will be, we want to say the following. We want to go row by row. That's usually the sequence. For the first row of index 0, I want to go to colon 0, colon 1, colon 2, and colon 3. And then I want to also go for the second row at index 1. And for that particular one, I'm going to go for 0, 1, 2, 3. So eventually, I really need 2 loop counters. So 0, 0, 0, 1, 0, 2, 0, 3. You can think about for the first dimension, I just need 1 loop counter, maybe called I. For the second dimension, I just need another loop counter, which will be J. Okay, so that's a conceptual idea. I wouldn't go too much deeper into it. For this week, we don't really need it for the ultimate solution for the distance, for the mileage calculation, but at least you get some idea. And you can think about the loops yourself, and I'll do some detailed tracing with you maybe next week when we have more time. Okay, but we're going to use this notation for sure. So you can think about this is going to be a row, and the other one will be the column. So this part will be the row, this will be the column. Okay, you can think about a row is like an index into the first dimension. And the column here will be the index into the second dimension. Okay, just a note. All right, let's go back here. And how do we do that? We need a nested loop, basically. So we'll simply say for integer, I can say R, standing for row, initialized to be 0. Remember, row index start with 0. R less than, how many rows do we have? In here, the number of rows over here correspond to the length of list 2 over here, right? You can see the length should be 1, 2, and 3. So that should be the number of rows. Less than, let's say list 2a and 2b are exactly the same. Let me just say 2a. Okay, let's say 2a dot length, and then row plus plus. Okay, so what I can do is I can say sys out over here. So I can say row R. Okay, and then I will say plus over here, and then let's say colon. Okay, so that'll be the first row. And then for every individual row, I'm going to go for, let's say if I'm in this particular row, I want to go over column by column over here. So what should be the length? How many columns do I have? It's really about the length of this particular array. How do I refer to this particular array? You'll be list 2 at index 1, right? At index 1 is referring to the starting address of this particular array. Remember I mentioned to you before, in general, the length between each individual array in the second dimension, they do not have to be equally long, but that's something we'll worry about next time. So what you can do is you can say list 2 1. So it's really referring to this particular array. How many slots are there? You can say this dot length. That's basically what you can do. All right, let me go back there. So I can say here, I can say for integer c standing for colon, starting from 0 always, and so now colon less than. So I can say list 2a, right? And then add index row, right? And then dot length. And then C++. That's basically what I can do. So hopefully you can understand about this part over here. You can think about this part here. It's basically like if I got already list 2, 1. So list 2 and then 1 is pointing to this array. How many columns do I have? I got 1, 2, 3, 4 columns corresponding to the length of this particular array, which can be referred to by this expression here. So that's why I say this expression here dot length. But in the general loop structure, so it would not be 1 anymore. It would just be the row. Okay. Let me go back here. And then let's now just make it a little bit more predefined in printing. So I can say sys out over here. Let's say we start with some square brackets. We'll end it with some also some square brackets over here, ending one. And let me say I want to put it in the same line. Okay, you will see exactly why I'm doing this. And I want it to be a comma separated list, right? So I can say for every one of them, I'm going to first of all print out the element itself. And that's exactly how we can do it. You see 2a. So the row dimension, first dimension, and then column dimension will be C over here, right? And then we want it to be comma separated, and this is something you have done already. If the C is strictly less than list 2a r dot length minus 1, right? If that's the case, I'm gonna also print out the comma. Okay, and then the comma over here. And I don't want to be a new line just yet. And also we spoke about the difference between print and print line previously, right? So why don't we try? And if I execute it, you will see exactly like this, right? So row 0, row 1, and row 2. And then you can see this will be column 0, column 1, column 2, and column 3, right? So, and then it's comma separated list, okay? And for this particular nested loop, it's a very standard one. So if you got any trouble, try to visualize exactly what I did over here, and you can trace the loop. And for the nested loop structure, I will try to give you some flowchart to formalize its meaning, maybe in the beginning of next week. Maybe not this week. We only got some limited amount of time left. So I'll try to control. All right, let's now try to look at very quickly about how we can initialize the two-dimensional array using the other notation with a new keyword. Let's now just do the following. Why don't we just create another app over here? So you can say refactor, and then let me say app, let's say 1 over here. Okay, let's say finish. Okay, and then let me simply just go to over here, and let me right click on this particular app, and I want to paste it. Okay, just paste it over here. So we got app 2. Let me double click on that. And for this one here, I would like to do the following. Okay, let me just keep this handy. I still need it for printing purpose in just a moment. Okay, I'll show it to you. And then I'm just going to actually do from here. Okay, let's say I want to just do list 2. Let me just rename this particular variable. So I'll just say list 2. List 2. List 2. List 2. You know what? Let me, I changed my mind. I would like to show you the following. Let me just do it again. Let's say this. For this one here, let's say list 2a. Rather than using initializer expression, I'm just going to say new, all right, and then integer. Remember, in the case of one-dimensional array, you have to specify the size, and we do the same. So since it's now 2-dimensional, we gotta put 2 square brackets. We gotta fill in a number over here, and also we gotta fill in another number over here. And this will be the size for the first dimension. So the size for the first dimension will be the size over here. How many? 1, 2, and 3. In this case, there should be 3. And also the size for the second dimension. So for every array in the second dimension, you can initialize them at one go to say for every array over here, their size should be, let's say 1, 2, 3, 4. Okay. If you're using the new keyword version over here, so once you specify the size for the second dimension, every array in the second dimension will have the same length. You cannot really specify unequal length using the new keyword version. But if you use the initializer expression, I will show you that briefly next week. You can actually specify arrays of different length in the second dimension, right? But for the new keyword version, you just cannot. So the array we want to get will be 3 by 4, right? 3 by 4, and recall this over here. So it'll be 3 by 1, 2, 3, 4. 3 by 4. That's what we want to do. And the initially, we are simply just going to get. Let me just cut this over here. I could have just defined some helper method for printing purpose, but let's not bother. Okay. So now, if I just try to print it out, I will actually see every element over there is simply just 0. And this makes perfect sense. Remember, if you simply use a new keyword to create an array using the new keyword, in that case, you will just get default value for every slot. And because every slot in the second dimension should just be an integer, so default value will just be 0. And let's now try to initialize them. So there are different ways for you to initialize them. Let me show you the approach one. Approach one would be, let's say this. We got row 1, row 2, and row 3, right? I can simply do this. Let's say this. I can say my list 2, right? List 2A. I can say list 2A at index 0. At the moment, it's actually storing the starting address of just another array, right? I can say maybe this is reassigned simply just to row 1. Right? And then I can also do another one here, row 2, and also row 3. I'll visualize this with you in just a moment. Okay, so 0, 1, 2. Okay, and then after this, if I try to do the printout again, okay, I'm actually going to get, you can see this will be the second one. So that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But exactly how is this done? Let me visualize that to you on the iPad very quickly. Okay, so let's now trace this fragment of code which we just executed. It's working, but let's see exactly how it is working. Let's now try to do line by line. So here we got, again, we got 2 dimensions, right? Let's be careful over here. So here, this will be the first dimension, and this part here will be the second dimension, right? So that's what we have. And for the first dimension, we simply got size 3. And for the second dimension, we got size 4. So it's a 3 by 4 table or 3 by 4 matrix, depending on which term you use. So let's now visualize using the second way, which I highly recommend it. So first dimension is going to be of size 3. So what I will do is list 2A stores the starting address of the first dimension array. There's only a single array in the first dimension. So we got list 2A pointing to the start of just an array of size 3 over here. So we got 0, also 1 and 2. Indices will be 0, 1, and 2. All right, and then for the second dimension, so for every slot of the first dimension array is going to store the starting address of just another array. And now we are saying that a particular array is going to be of size 4. So it's going to point to this particular array of size 4, and then every element there is going to store the default value for integer, right? Integer will be simply 0. Let's write it down. It's going to be the same structure and contents in the beginning. So 0, 1, 2, and 3, and the value will just be 0, 0, 0, 0, which is what you just which I also showed to you by executing it. So let me just copy the same structure over here and then paste it for the second slot, and also the third slot is going to be the same, right? Just like that. Okay. And after this, so you can think about this is the consequence of executing this particular line for initializing it. Right? You can see it's kind of the visualization will be very similar as before. It's just that we don't have any contents over here, just default value. Okay. Let's now create row 1, 2, and 3. And for those you're pretty familiar, just visualizing one-dimensional array like how we did it before. So let me just put maybe purple over here. Okay. So we got row number 1. Okay, so we're gonna get what might be the best way to do this. You know what? Let me change the layout over here. Let me just put it here. Let me just resize that a little bit. Okay, you know, put it here. Okay, good. And then I'm going to just create row 1, row 2, and row 3. So row 1 is basically pointing to this particular array over here of size 4. You can see 1, 2, 3, 4. So it's going to be 1, 2, and 3. So 0, 1, 2, and 3. Okay, let me just save some drawing for later. So let me just copy this particular array. Okay, let me just use that. Okay, good. And for row 1, it's going to be 1, 2, 3, 4, right? So it's going to be 1, 2, 3, and 4. So what about row 2? Row 2 will point to the starting point, will point to the start of just another array of the same size. So this will be row 2. And then row 2 is going to be 5, 6, 7, 8. It's going to be 5, 6, 7, and 8. And similarly, row 3 will stores the starting address of just another array of size 4. So this will be row 3. Row 3. The contents will be 9, 10, 11, 12. 9, 10, 11, and 12. So this is what we have done so far, right? You can see that. So basically this part over here, just creating 3 separate array objects over here, right? That's what we have done. And then let's now try to do this. If I say list2a 0 is reassigned to row 1, basically what it is doing is it's going to copy the address, copy whatever address that is stored in row 1, and row 1 actually store the starting address of this particular array. Copy that starting address to the first slot of list2a. Where is the first slot of list2a? List2a, the first slot is really over here. So now for that one there, rather than pointing to over here, it's now going to store the address of whatever row 1 is storing. So it's now going to point to this particular array over here. So now that one becomes, you can think about list2a. If you try to do some comparison for assertion, if you try to say list2a at index 0 equals row 1, they are referring to the same array objects, right? You can see list2a, and then index 0 is now pointing to this particular array, and row 1 is also pointing to it. So now if you try to do this Boolean comparison, it's going to give you true. Okay, that's in the side. You can also do that. You can try that on the Eclipse as well. I'll leave you to that. Okay, and then we're going to do another one here. So here, when we try to do list2a over here at index 1, list2a at index 1 over here, so that one there is actually going to store the starting address of whatever row 2 is storing, right? It's storing the starting address of this particular array. So rather than pointing to over here, it's now going to point to this particular array. And we do something very similar. And list2a and then index 2. And then that one there, rather than pointing to this array, is going to point to wherever row 3 is pointing to. Okay, so after this, right? So you can see the consequence of these over here. After these assignments over here, after these, we actually reassign essentially the two-dimensional arrays that's really being pointed to. Okay, so these are the consequences. Let's now try to do one more thing, and then we are done with the introduction, so we can move on to the ultimate solution. What if I want to change something in the array? Pretty easy. Let's say I really want to modify, let's say this particular element, let's say here. I want to modify this element over here. Rather than 7, I want to modify that into, let's say, -1. So where is this particular element? It's actually, how do we get there? So it's going to be index 2, colon 2, right? And also it's actually at index 1. So in total, we're actually going to do the following. We're going to say list to A at row number 1, and also go to column number 2, and then we want to reassign that to -1. That's what we should do. So list to A is pointing to this particular array. Go to index 1 is referring to this particular new row, and then go to index 2 over here and change that to be -1. That's what we want to do. Okay, let's now try to do that. So I will simply say list to A 1 and also 2 is reassigned to -1, right? And then after this, we can simply just copy and paste this fragment of code to print out the contents of the 2D array. If you try that, and you're gonna see over here it's being modified to -1, exactly how we predicted that, right? So don't worry too much about the duplicates of copy and pasting this particular fragment of code. We just want to print out the elements of the array. And then you should really pay attention to the basics about how you can initialize the array using either initializer or the new keyword. And then how you can get access to a particular row or to the particular intersection by some specified row and column, and how you can modify a slot in the array, or how you can modify the row. That's something we have spoken about thoroughly in this part of the tutorial video. All right, so now the final part for this week will be to now code up the final solution, version number 2, for our mileage calculation.